Functions can either be discrete or continuous. Discrete means that there's separations in the graph. Continuous means that you could take your pencil and draw all along the entire graph without having to lift up your pencil. So the one on the left where we've got some points there, that's a discrete graph, whereas on the right, there's a straight line. You can just draw your pencil along that whole line. That is a continuous graph. When we have a discrete graph, we're going to have the domain be discrete as well. So you can see for this one, it says x is, for the domain, x is equal to -2, -1, 0, 1, and 2. That means those are the only x values in the domain. So we are not using all possible x values here. We're just using those 5. So what this is going to do is this is going to give us a discrete function. So to graph this function, what we need to do is just take those 5 values, plug them into -2x minus 3, and then plot them. There's the table of values, and I've also plotted the points on the graph. Now this is it, just as is. So we are not going to draw a line between these points. If we were to, so I will for a moment, but again this is wrong. So if we were to draw a line through these points, we would have things like, you see we have right here an x value of 1.5. 1.5 is not in the domain, so we should not have an x value of 1.5 anywhere on here. And all those values between the red points, any number outside of the red points, those are not in the domain. So this right here, this is the entire graph. This is a discrete function. So there are certain things that you might use a discrete function for. So for example, if you're talking about the number of people in a room, or if you're doing something maybe with a population, you're never going to have like 1.753 people. That's just not going to happen. So if you're talking about people, that's going to be a discrete function, or maybe something about the number of cars on a road or something like that. You're not going to have portions of cars and portions of people. So these would be things that you would use a discrete function for. A continuous function, again, is one that is continuous. You could draw along the line with your pencil, and you could fill the entire graph along with your pencil without having to lift it off the paper. So when we have something for the domain like x is less than or greater than something, or less than or equal to, or greater than or equal to, or if it just says all real numbers, these are going to all be continuous functions with those domains. So let's look at graphing this. Now for this one, since we don't have specific points, let's go ahead and take a look at the fact that it's in slope-intercept form. So we have a y-intercept of 7. Well, we want to be careful here because in our domain it says x is strictly less than 0, not less than or equal to. So we actually don't want to include the point that has x equals 0, which is the y-intercept. So we're going to draw an open circle around that point rather than filling it in. Again, the y-intercept is the place where x equals 0. So if our domain is x is less than 0, strictly less than, not less than or equal to, we need to draw an open circle around that to exclude x equals 0 from our graph. But then we want x values less than 0 and only less than 0. So we are not going to go to the right of 0. We're only going to go to the left. And so if we're looking at the slope of 1/2, that would normally be going up 1 and to the right 2 to get a point about right there, or exactly right there. But again, we don't want x values bigger than 0. So instead of going up 1 and to the right 2, let's just go the opposite direction. Let's go down 1 and to the left 2. Down 1 to the left 2, and I'll just keep drawing more of these to get a nice accurate graph. And then we're going to draw, but then stop. Stop there at x equals 0. So that would be the continuous graph with